to the north, above the Arctic Circle, lies the bleak, frozen wilderness of Greenland. 9/10 of this polar land mass is permanently covered by a gigantic mantle of ice and snow, roughly 10,000 feet thick at its center. Nothing lives or grows on the ice cap. No caribou roam its icy wastes. No moss or shrub can withstand its winter blizzards. At an altitude of 6,000 feet in the interior of the ice cap, and about 800 miles from the North Pole, is Camp Century, a city under ice. Designed as a functional laboratory to study the secrets of Arctic survival under polar conditions, Camp Century was built during the summer of 1960 by the Corps of Engineers, United States Army. To build Camp Century, everything had to be brought in by aircraft or sled: construction materials, iron beams, lumber, steel roofing, snow plows, everything. Smaller vehicles to be used at the building site were transported over the ice on large sleds drawn by D9 tractors. This 20th century version of the covered wagon train is called a heavy swing. To supply power, heat, and light to Camp Century, an unprecedented extra was added: a nuclear power plant, the PM-2A. This portable plant was built as a set of air transportable components which were interconnected after installation. The reactor complex was put into operation during October 1960 and functioned successfully until the fall of 1963. At that time, a decision was made to remove the nuclear plant for reuse elsewhere. As a prelude to this operation, the nuclear fuel was removed in September 1963. At Fort Belvoir, Virginia, a planning cadre was assembled to draft procedures for the relocation undertaking, with special emphasis on the radiation problems anticipated. This was to be a joint effort of the Army Engineers Reactors Group, directed by Colonel Robert B. Berlin, and the Army Research Support Group, formerly the Polar Research and Development Center, commanded by Colonel Robert J. Geeson, and later by Colonel Neil B. Prentice. The Nuclear Power Field Office, whose chief was Lieutenant Colonel O.F. Haney, developed all technical and radiation safety procedures for disassembly and preservation of the PM-2A. Personnel of the Reactors Group, the Research Support Group, and the 46th Engineer Battalion were selected for the complex work at Camp Century. As service on the Greenland Ice Cap called for the utmost in physical fitness, an intense physical training program was conducted during the weeks preceding departure. To cope with the immense relocation effort, more than 800 supply items of various types were procured through separate supply channels. To provide easy observation of any item failing to meet required shipping dates, a graphic schedule of procurement and shipment was maintained. In preparation for the primary task ahead, Captain J.P. Franklin oriented work crews on the trench layout and component dispersal pattern of the PM-2A. First, all cargo, spare parts, and tools in the storage building would be packed, and the offices and laboratory equipment in Trench 5 transferred to a new area. After preparation for shipment, the control skid would be moved out from the east end of Trench 5, followed by the switchgear skid, the turbine generator, the condenser, the heat exchanger, and the air blast cooler in Trench 5. The air exhaust ducts would be disconnected and left in place. The two air blast coolers in Trench 2 would then be moved through the trench intersection, turned, and pulled out in the same manner as the preceding skids. Lastly, the feedwater skid in Trench 3 would be moved through the open intersection and out the east end of Trench 5. In Trench 4, the reactor trench, the hot waste tank would be removed and the snow shielding wall demolished to allow cargo removal from the north end. This segment is a model of the reactor building. The associated tanks around the reactor system would be removed through the north end of this building by use of a crane. The north end of the vapor container would be removed and the reactor skid and steam generator hauled out separately to the surface. The vapor container, the last major component of the power plant, would be disassembled and moved in two sections through the building and up the ramp. With the planning and training phase over, all equipment and records were packed for shipment by air. Final letters written and farewells said. On March 16th, the advance party was checked out for departure and boarded buses at Fort Belvoir to start on the first leg of their northward journey to Greenland. Arriving at Thule Air Base, they proceeded along the uphill road to Camp Tuto, roughly 15 miles away. Entering Tuto, they got their first views of the awesome ice cap, their home for the long weeks ahead. First order of priority upon arrival at Camp Tuto is clothing, and here at the support group supply room, the new arrivals were outfitted with every item of Arctic gear necessary to cope with the polar climate. The advance party flew off ahead of the main group to inspect conditions at Camp Century, which had been closed during the preceding winter. At the edge of the ice cap, along the ramp road, a heavy swing was loaded with equipment needed to reopen Camp Century. Lumber to crate the PM-2A, and heavy machinery to remove reactor components from entrenched positions beneath the ice. The swing crew lived in sled-mounted quarters called wanigans. Thompson trailers with low-pressure tires also accompanied these supply trains. On March 31st, 1964, the first heavy swing of the season moved out for Camp Century. It chugged across the ice cap at about 2 miles an hour and completed the journey in approximately 70 hours. Even during summer, however, sudden blizzards and the dreaded whiteout can rage across the ice cap without warning to stop everything in its path. On April 5th, the swing arrived at Camp Century, and unloading began immediately. Among the first items was lead for radiation shielding. To clear the ramp into Trench 5, a Peters snow miller, used in Switzerland to clear alpine passes, proved its worth. In Trench 5, preservation and packaging of small components began. Tools were collected and boxed. Delicate instruments, such as meters, were packed carefully in separate cartons and then placed in a large container to withstand the rough journey ahead. The maintenance shop and laboratories were dismantled so that heavy skids located farther back in the trench could be moved out. Piping filled several large crates. Dismantling and preparing machinery in Trench 5 continued. Pipe flanges were sealed to keep out moisture. Circuit breakers from the switchgear skid were crated separately for maximum protection. Slotted angle irons were used to build protective frames around the skids. All available hands pitched in and helped. As each frame was completed, a Herculite shroud would be draped around it for protection. Heavy-duty hydraulic jacks were used to lift the assembled skids. They were then winched on to sleds. All sled-mounted cargo was then hauled out of Trench 5 and packed in a holding area, pending departure of the first of a series of swings for Cap Tuto. Weasels pushed smaller sleds to the surface, loaded with 55-gallon drums of contaminated waste. Triple-walled cartons, packed with sensitive components, were also moved to the surface by Weasel and loaded into the Conex containers. The most critical part of the job now began: removal of the reactor. The crew started by clearing a hatch above the spent fuel tank. This cask, weighing 6 tons, was lowered through the hatch into the reactor chamber. It would hold the thermal shield. Because of the high radiation fields around the shield, unusually thick lead sheeting was required for the container in which it would be shipped. As weight limitations on cranes at Camp Century prevented use of a single 14-ton cask, a lighter cask within a cask was employed. Nuclear power personnel lowered the inner cask into the water-shielded spent fuel tank. After the thermal shield and absorbers had been placed in the cask underwater, the cask was lifted to the surface, where it was placed inside a larger 8-ton lead-shielded container. The heavy box made to hold the steam dome was lined with plastic. Sheet lead was cut and bent to fit inside the crate for radiation shielding. The steam dome was then placed inside this box and sealed. Similar procedures were followed in packing the reactor head and the dry cap cover. Throughout all phases of the dismantling operation, Army health physicists maintained constant checks on radiation levels. These boxed components were then loaded into larger crates with additional lead shielding and rechecked for radiation danger. Up on the surface, work began on removing snow from steel arches above Trench 4, the reactor building trench. During removal operations, a collapse in the snow wall temporarily buried the hot waste tank and left the arches hanging in a hazardous position. Because of this situation, salvage of the arches was abandoned and heavy equipment was employed to remove the twisted steel. On May 26th, work began on removal of the reactor shielding wall, 24 feet thick and 30 feet high, This snow wall was lined on both sides with ice-filled drums. As all attempts to reduce it in the conventional manner failed, explosives were called for, and demolition of the wall accomplished. The spent fuel tank was lifted out of its enlarged hatch opening during violent weather conditions. Next, the 20-ton shield tank was removed from the vapor container and decontaminated topside by scrubbing with acetone. Since any attempt to reduce weight by removal of shielding plates on the reactor skid would have exposed work crews to maximum allowable radiation dosage long before the job was finished, it was decided to brace the plates in position. To shield the bottom of the reactor skid during transportation, a wooden pallet was floored with lead. Working under timed exposure to the high radiation field, the crew freed the reactor skid from the steam generator. It was pulled out a few feet from the vapor container. Steel and lead plates were then welded to the skid to afford more shielding protection against the high radiation levels encountered by the crew. The skid was finally hauled onto its lead-lined pallet and winched aboard the Seagull. It was then moved from Trench 4 to Trench 5. Work on shielding and packing could be done more efficiently in this area. Back in Trench 4, disassembly and removal of remaining components continued. At various stages of the dismantling operation, officers from the Research Support Group and Engineer Reactors Group visited Camp Century to observe the degree of progress achieved. The steam generator was moved from Trench 4 to 5 for final preparation. The vapor container was disassembled for movement to the surface in sections. Steel beams were used to brace the inside against buckling. After weeks of difficult and exacting labor, the last major component of the PM-2A, the vapor container door section, was hauled triumphantly to the surface. Packing continued on the surface above Camp Century in sunny but sub-zero weather. After all components of the power plant had been removed, Trench 4 was filled in as a safety measure, and final policing of the area began. Radiation levels remaining at Century met the high standards of decontamination set by agreement with the Danish government. With the last components of the portable reactor safely aboard the 6th heavy swing, the downhill journey to the coast began. On arrival at the loading ramp adjacent to Camp Tudo, all cargo was transferred to truck trailer. At this busy sled terminus, a number of improvised rigs, such as this Bailey Bridge ramp, were used to get the heavier elements transferred from sled to wheels. As soon as the trailers were loaded, they headed down the ramp road for Thule. At the storage area in Thule, officers of the Research Support Group inspected all units of arriving cargo. Here, a heavy-duty crane proved invaluable for handling the larger items of reactor machinery. On July 17th, the Coast Guard icebreaker West Wind plowed through sea ice to open a channel for the Greenville Victory, first ship of 1964 to enter Thule Harbor. Since daylight in Greenland during July is 24 hours long, loading crews were able to move crated cargo aboard ships as soon as it arrived from the storage area. As the last of the PM-2A components were placed safely aboard the Greenville Victory on July 26, 1964, it suddenly became apparent that our task in Greenland was over. Thanks to the professional skill, determination, and resourcefulness of dedicated men, the mission had been accomplished successfully and well ahead of schedule.